Okay, welcome to the class. This is CPE 325 Big Data. I'm not sure if you heard me clearly or not, because I actually not have not been. I'm not familiar with using the the computer at the university for the recording. Usually, I use my set at home. But well, I'm recording right now at the university. So is it clear in terms of voice? Yes, right? Okay, good. Right. So the topics for today will be introduction, right? I will introduce you to our class here. We will discuss about the criteria of the class, the score, and the topics that we will cover. As you may have noticed that there is already one class that we need to cancel. Is the 4th, I think, the 4th of September, right? Because the government just announced that that will be holidays, and because of that, my classes will be affected for both this one and the other one. Right? Okay, so this class will be there will be two of us that are responsible, and the TA Y there. I will be responsible for the first part of the class before the midterm exam, and Ajahn Rashawit will take care of those courses, those sessions after the midterm exam. All right. So let's move on. Then discuss about the class structure first. The class, we will have the evaluation in this form. The evaluation will be in terms of examination for 60%, right? 30 of them midterm examination and another 30 for the final examination. And the laboratories are the lab that we will have for each of the class, designated class. We will have lab later, which each of these will earn you the points in this as well. So if you do it correctly and submit it on time, it should be fine, right? We will use LEB2 as the main submission place for that. So I will create LEB2 starting from the next week, so that you can submit the work to the LEB2. And for the last part is the term project that you need to decide on what you want to do. Right, this one will be different from your data model. In a data model, you can like select a data set, right, and then perform visualization analysis. But for this one, you need to select a project and do the project in terms of the big data itself. You can create the workflow. You don't have to work on the model. You can create a workflow. You can create a type of BI visualization from the data workflow that you choose. So it depends on the design, and that will come at the end of the terms. Right. The topics that we will cover for this year include this. I think you have not been familiar with the Python, right? Have you had any experience with Python before this? Sure, you are second or third year, I don't remember. Not much. So some of you know, and some of you don't know, right? So that should be fine, right? I will provide a brief review and focus particularly on the usage of Python to perform data operations, right? For the Python review, I will put that in the next class as well. So the next class will be the review of Python and the use of Python to perform data preparation. And then it will be about, after we prepare data, we can use Tableau to perform visualizations. And I will cover briefly on how to use machine learning, how to do machine learning in Python, right? So use the scikit-learn to perform machine learning, create a machine learning model. And then because you see that this week the lecture is canceled, it will be shifted to next one. That means on the 11th September, we will have Python machine learning and Hadoop, which is the system that could allow you to distribute the workload and then and computing and files to multiple systems. So you learn about that afterward. And lastly, for my part, will be about Hadoop MapReduce, right? So these will be covered before the midterm, and there are about 5 labs there. After the midterms, starting from October 9, you learn more tools on the big data platform, including how to perform data integration, meaning that the data, the incoming data coming to the system, and the data service, which is a way that you can provide data out of the system. Okay, and then about the operation in Spark, about creating the workflow management and the concept of data governance. This topic will be covered by Ajahn Rashawit after the midterm. All right, and finally, we will have term project presentation on the 27th of November, and then final exam. That's it. All right. So these are the information about the course, and our course will cover the topic on big data analytics and big data technology. So we will take a look at different tools, and also in your project, you can choose the data from Kaggle to do the work, or you can create a data pipeline to present to us. Any should be fine, given that they are related to the topics that you learn in the class here. Okay, so before we begin, any question? Do you have any question first? It can be regarding the grading. It can be regarding the topic itself. Let's discuss before we go on. Usually in my first class, I will have the introduction to the topic. You have already heard some of that in your data model class. I already present the why you need to learn about data model and visualization and data science in the data modeling class. But for this one, what we will take a look would be on a different point of view. Why, again, you need to use big data, when you should use big data, and when you should not use big data, right? So big data is not the answer for every questions, right? There, it is a system, it is a solution, but the solution would be suitable for certain questions, right? You need to think about that. Right? What types of applications are suitable for this type of systems? Any question before we begin? Can be about the class format or whatever. You can, if you are not sure, or if you do not feel comfortable, open the microphone and talk, you can just type in the chat, right? Just like in the last class. I'm fine with that. Okay. Any questions? No? No? So if not, then we'll begin.
We have one question. Do we have to learn this course online in whole semesters?
From the university policy, which I'm still waiting for it as well. There isn't any specification on the class format that we need to take. So yeah, I suppose so. I think we still need to learn it online. Well, talk about this one. I would like you to think about this one factor. Although right now everything seems to be fine, but this is like an ideal, what should I say? An unrealistic bubble right now. It is an unrealistic bubble. What does it mean? It means that if you think about it, right now we close the border, no travel coming in and out. And in terms of the country, we cannot live like this. So eventually we have to open the border, right? Once we open the border, there will definitely be the traveling going on for sure. Just like now that you see when you can now go to sightseeing at different provinces, business opening. And yeah, and finally, you need to kind of think that what will happen if we have cases again, then it might go to the online again. Well, that might be it. So for me, actually, if we can teach offline, then I'm all for it. But because of the university policy right now, yeah, we still have to learn online like this one. There's another question. What about the exam? Is it online or offline, right? Yeah, that's the thing. I still do not have. Let's put it this way. Let's speak straightforward, truthfully with you guys. I still do not have any ideas. What should I do? Well, I'm still waiting for the guideline from the university on what should we prepare for that. But so far, there are no guidelines at all. So if it's up to me right now to say taking care of the risks or of those risks, I not risk of infecting, I mean risk of changing the project requirement, changing the class requirement like this one. The thing that I can do definitely is to do the online exam, right? Because just like last time, I already have a way to do the online exam. Well, I will be more lenient, make it more easier than the last time, for sure, right? So possibly it will be online, right now, and because I still do not have clear guideline and on the options that can be taken. You may have heard about the news that the what do I call it, in the government, the Ministry of Higher Educations, they mentioned that we can have class offline. Although they mentioned that, but the guideline that coming out was like, okay, you can have class online or offline or whatever, just think about it yourself. That type of guideline, right? So what do we do? Then we need to still, well, once we know that, the thing that we can do is we need to wait for the university, right, to tell us specific guidelines. Or I could just decide myself. But the reason that what I can decide on myself is that, okay, for sure I can have everything online because that's given that we can have online like that. But to have offline, that will be a little bit problematic, right? Because to have the offline, it means that I think the university right now is afraid of the, because the university is also governed by Bangkok authority, right? BM, for example, whatever. The Bangkok authority, right? And the Bangkok authority have this regulation that right now, if we are going to conduct the teaching, the university has to provide the space that is up to their standard. That is, each of you guys have to sit at least 1.5 meter apart. It sounds ridiculous, I know, right now, because when you go to a restaurant right now, you can sit closer than that. The problem is that this policy is still active and the university cannot do anything about that. Yeah, so it's a whole mess of regulations and I think the lack of communication of these organizations. So I do what I can do, right? I do what I can do. I can teach you, whether it's online or offline. I can teach you. So yeah, so that's why it goes like this one. Okay, so let's put it this way. We'll learn online until there is an option for us to clearly switch to offline. Okay. When there is a clear guideline or there's a types of clear, like the thing that we can, okay, let's say we can have exam or we can have presentation offline at the department, then we'll do that, right? So bear with me, and if you see any university communication that maybe I might have missed, tell me, right? All right. So I'm still following the guidance from the of both the department and the university to do these things. Right. Other questions? Don't compare university to pub. All right, it's different. Well, for pub, for university, it is what should I call? It has to follow the rules. Those organizations does not have to follow the rules, so that's different there. So, well, since it has to follow the rules, so when there's rule, it has to follow. Except that otherwise it will be except that if the university leadership has this like initiative that, oh, they will not wait for the author to tell them what to do and then just they just issue the guidelines before that. So I hope that happens. I really hope that happens, that we have like such a leadership that take action really quickly. But right now we have what we have, right? So let's work with it. Okay. Right. So should be enough for that. No, maybe. Right. So any question about this, about the topics? So basically, I will teach first half of the semester. Ajahn Rashawit will teach the second half of the semester. Right. We both are. We would have experience teaching this stuff to company outside, and we have been teaching big data for, I would say, almost 8 years. No, almost 6 years, starting from 2014. So this is quite some time already. Okay, so if no further question, then let's continue, right, for today's lecture. Okay. Okay. Oh yeah, I discussed this with the class on Monday. So there are pros and cons for online teaching and offline teaching. Okay. What do you think is the the advantage of online teaching? Any idea? Online learning, I'll put it this way. What is the advantage of online learning? Come on, talk to me. You can just type, right? Comfortable. You can rewatch the video. Comfortable. I'm not actually. You can see it. I still have to. Actually, I do not feel any comfortable at all, because I like to walk and talk, right? Not just sitting and talk. And well, it's kind of well, yeah, comfortable. I mean, you guys probably now lying in the bed, right? Watching anywhere, right? Watching the lecture like that, and but that will make you feel sleepy, especially in the afternoon. So maybe stand up, or well, I do not have a chance to do that, so you can. Well, sit upright, right? Do that. So yeah, you can rewatch the video. I'll upload the video as usual online onto that. And I already have the video posted into YouTube. If you want to take a look at that, you can do that as well for the whole course, right? Last semester, big data in the last semester. For this semester, I make a revision and discuss with Ajahn Rashawit that he should come in and then also add the elements in data governance and also in workflow, right? In workflow management, as particularly these two topics, which will be useful, right? Right. So this will be the way that we'll do. Online is like that. You can rewatch the video. Offline is, well, you can have personal contact. You can talk to one another, and that's good. I think like that as well. I hope that return soon. Although, well, I don't know when that will be. So, well, let's do it the best way that we can right now. So I will teach it the best way that I can. you can talk to me whenever you want. I think you already know that, because some of you may even send message to me like almost midnight, which is fine because I'm still online there. You can just send me, ask me things. So yeah, you can do that, no problem, right? So see, online is not that bad, right? So let's take a look at the introduction today. So today I'll introduce you to what is big data and why you should learn that. Okay, so you may have already had this experience that when you go into a restaurant, when you go to buy something online, you have to pass through a step, right? For example, if you want to know information about product, you may call the call center. Once you call the call center, actually data has already been gathered, right? What types of data that have been gathered here, right? Anyone can share the idea here? What are the data that may have been collected at this point? Location, what else? Customer name, phone number, maybe voice, right? The voice of customer calling in, information about what? About maybe about that transaction itself, right? So the data that are collected here can be in forms of just a table. It can be voice, right? It can be, some of you may think about it as a location of the call if we talk about the telecom company. So, well, there might be many things here, right? And when the call center answer the question, also data are collected here. Can be the note from the call center, can be the data about customer that is calling, or maybe the sentiment, whether that customer feel mad or not, right? So that's might be the step. And once you are interested in something, you may browse it online. And once you do that, the data are gathered here as well. What types of data are there? Data that may be gathered by browsing the online store. Type of device. Okay, what else? So I like you to think about the format of data, right? If your data is about the type of device, and then it might be like what on which link that you click and what device they are, right? So that's correct. The product that have been searched, correct. And it can be a tabular format, like in database that you have already learned, or it can be a file, right? It can be a file storing at the web server, or it can be the log, the log of data that it contains the session and the browsing web that has been occurring for that session. And then once the customer are interested in that and click on add to the cart, you have the product go to the cart. And that data will also happen often in forms of the database or in forms of the cookie in your computer. And then you pay for the service, and come on, where is this? And then you got enrolled and become the customer and use. This is called the customer journey. And you can see that there are different types of data that can be collected throughout the process. Here, even buying offline right now has a chance to has an ability to be what you call to have data generated and gathered. Right? Let's watch. I'm not sure if you hear this. So if you do not hear the sound, just send some signal. Do you hear the sound?
No.
No? Right, let me try to find a way to put the sound in. Should be audio setting.
In share option, you have to share the computer sound.
All right, thank you. Share computer sound. All right.
Welcome to Amazon Go. use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart.
How does that happen? Right? How does that happen? That anything that they want, they kind of pick up, got added to the cart. What do you think happened here? Can you make a guess on what happens when you buy offline like this? How come that the store know which product, right, have been gathered? Right?
If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going.
All right. So it means that, yeah, I use image processing, but there are lots of customers, right? So let's just think about where do these processing occur? There must be some places, right? So there will be a lot of sensor data, a lot of image data, the customer data, right, that are in table. So how do they perform computation? How do they write a program? And where do they write those programs that would kind of process all of this when there are like millions of transactions occurring? So that's the requirement there. And you can see that there are a lot of data generated, different type of data, variety of data, right? Data with uncertainty. Right? So to have a system that can collect them, I think that is where the big data can be used. Okay. It's also true right now when we are buying, even for the offline, we can still gather data, and there are ways, right? Right now we can use the QR code to buy and sell, and there are like vending machine that you can also use to buy and sell. And right now, so and even the application like Grab and like delivery that now bridge the gap between the street food and the online transaction. Okay, so this market will grow eventually because people will transit from using cash to non-cash. Right now, you can already see some of these in Thailand, that you can use QR code to make payment. Now, this course will be about the big data, the underlying mechanism, underlying system that serve in those applications. All right. There are different types of data. You have the data about the demographic data, about the unit of analysis that you want, which can be customer, or it can be device, or the thing that you are interested in, right? Demographic data, you think about that. We have relationship about one-to-one, like one demographic data per one unit of analysis. Like if we talk about customer, right? Customer can one customer, we have one age, we have one gender, we have they will have one mobile phone type that they use mostly. So that's the demographic data. The transaction data will have the so if I were to write here, I will write it as, this will be as 1-to-1. And this will be one, let's like that is too many. Difficult. Big M, one too many. That means one unit of analysis may generate many transactions, right? Like when you purchase or book the travel, or when you play games, just yourself, you play a lot of time, right? So that's transaction data. Interaction data occur from unit of analysis interacting with themselves or interacting with the company, like calling in, or clicking web stream, or sending email, right? Behavioral data from the derivation of the above, the transaction and demographic, to get the thing like the need, the desire on what the customer or what that unit behave, right? So these are the data that have meanings to the way that customer interact with the system, that a person interact with the system. But when you take a look at it this way, these data grow in different rate, grow at different rate. For example, demographic data, it grows at the rate 1-to-1. The problem is that if you have a large number of customers, say banks have 20 million customers, the demographic data itself is quite large. Analyzing them all together, that is already challenging, right? Transaction data, this is even worse. Transaction data grow in multiple to the demographic, in multiple to the unit of analysis. That means the more transaction occur, right? The more transaction occur per user, the larger transaction size that you have. For example, I provide consultant with the telecom company, and they have the number of transactions occurring for each second ranging to the range of like 100 megabytes. So you can imagine that just 1 second, just 1 minute, you have the data in the range of almost gigabyte. And then the rate of generation will be quite large if you want to perform computation that way. Interaction data will be large depending on the number of unit of analysis. For example, if you think about the social network data like Twitter or Facebook or Pancake, if you make a comment to one user or one customer, you create a link between your post, between yourself and the one that is responsible for the post, right? Creating a link. So when you view things as a whole, right? When view everything as a whole, that you see that these relationships arise from such interaction. But the size of the interaction will be quite large because it will be the magnitude of n squared, right? Where n is the number of unit of analysis. And lastly, behavioral data here. This behavioral data may come from the interaction data itself, interaction between the customer here and the item and others. So, and this often be in forms of the product of computation of modeling the above, right? So this is customer data from the customer journey. These data, you can see that they have different growing magnitude, right? Some of them, mostly they are in the traditional database form. That is, they are stored in the database. But right now, we have the trend is that you can now use the data more than just structure, right? You can always use unstructured data. Unstructured data like the log, the image, the location, from data from sensor, the map, and others. So these are the unstructured data that arise. However, database is not suitable to store these unstructured data because the database itself need to be defined as a schema. And if you want to store something like text into a database, right, the written text in database, you can store it in like one column. However, that column would not reflect any meaning, right? And that make people think on how to make it better in terms of processing the data rather than storing in database. So the idea is that there should be a system that can take care of the unstructured data and the structured data. Right? So that's a big data system. How do we define that the data is big data? Okay, with the new sources of data like behavioral data that may contain server log and clickstream, image and sounds, which are the unstructured data, the language, the text of the tweet, or the record on the of the survey and the sensors. These are the new sources of data that have certain characteristics. Like they would have a large volume. That's one thing. Big data need to be large in terms of the maybe megabyte or gigabyte of that. It can be online, offline, right? The data can be like online, large and online, like a web data. You know that it is large, but you did not store it yourself. It's now online, but you need to process it. That's large, right? And offline means that you are already store a large chunk of data and you need to process that. The data can be automatically generated that are from maybe systems, right? Generate data, and it can be manually created. The data, big data has another important aspect is that the big data refer to the data that is also have certain variety. It means that so it at least it has to be have large volume, right? But it also can have structured and unstructured data. So if you have unstructured data and large, yeah, you have big data. And if you ask whether you should store it, you should invest in building or buying the big data systems or not. It depends on whether you want to store them in the raw format and make use of them. If you want to do that, then that's the answer that you need. But if not, then you can just back it up to some to some like offline storage and just keep it there. Right? So big data is suitable if you want to make use of those data. So data can be large, data can be variety, can be like unstructured data like text, or structured data like the table, text image for unstructured, and the table for structured data. The data can be, may have these aspects of the rate of generation, right? It can be fast in terms of the rate of the generation, or big data may deal with the data that is not that big, but you need to have a way to analyze the data really quickly, right? That means once the data, like social network data, you kind of gather the social network data online, and you might want to predict or make assessment of that automatically. That means the delay from receiving the data and prediction need to be short. And how to do that, right? One way to do that is to create a stream or a pipeline from the data coming in to analysis so that it can analyze very fast. So the rate of analysis also relate to that, right? If you want to have fast reaction system, then you might need a multiple server to do that. The last one, the veracity, right? The veracity refer to that the big data may have all these aspects, but it may also have this. That is, the data may be unclean because, for example, you have image data from sensor, from the surveillance camera, then it can be like unclean. The data may be untrustworthy. For example, if you download the data from internet, from the website, some of them might not be trustworthy. Some of them might be. Like you want to create a system that understands e-commerce in Thailand, and then you crawl the data from the store in Thailand. Some of the store might be fake store, right? Where you want to know which is that, so that you can clean them. So some of them might be untrustworthy. So there are these aspects in the data. Right, so the challenge in big data would be in terms of these four aspects, right? We have the volume, velocity, variety, and the complexity of the data. Veracity refer to the trustworthy, like the data will have different complexity. For example, if we talk about the media like image and audio, the media itself has a large size you compare to text and author, right? When you store the data, it has certain variety in terms of it, and the rate of generation is quite fast, and the data itself is unstructured, quite complex. Comparing to a simple data storage, which you have large size, also maybe high velocity, high variety, but it is unstructured, right? On the other hand, if we take a look at the sensor data, or max all of that, because it generates like every second or every 5 seconds. But it is more like a structured data. So in terms of the complexity, it's not that hard. So different data would have like different challenges in dealing with them, right? The big data that used in different types of media here would require it to be more specific to that type of system. For example, if you use the big data to deal with something like a machine and log system, you need a big data that can react very fast because of the velocity requirement. But if you create a big data to store the archive or the docs, then it might not need to have like a very fast response, but it will need to be able to store a high variety of data in unstructured format. So yeah, so these are like the requirement of data that you can think about the nature of data when you come to work with it. So Chenua is one of these here. I have high velocity to generation, high volume, and also unstructured. Once you have data, then it comes to the analytics. Right? The analytics can be in terms of descriptive analytics that try to find what happened. Right? In that case, the data can be gathered in terms of the data warehouse. That is, you have multiple system together, and then you perform the process called ETL, extract, transform, load. This process is basically select the data that you want and transform them and load them to data warehouse. That's the ETL. Once that's done, you can use the business intelligence tool to perform analysis of the data warehouse. Right? You learn this I think in the next semester, right? With Ajahn Anchalisa on the BI, the business intelligence. But if your goal is not to just perform descriptive analytics, but your goal is to make a forecast, to project, to predict the outcome, then you need a system that is in the developer environment, a system that allows you to write a program to create a script that model the data and make prediction, and should be able to handle different type of data, not just the data from data warehouse, but also the data from image and sensor as a files. So data lake will help you in that. Data lake itself is an idea that you can think about big data as a lake. And for the lake, you will have the stream, the upstream, the stream that flow, the river that flow into this lake. So you can create those streams to copy the data from the source and flow to the lake, right? And once the data in the lake, you can make use of them in whatever way you want. Right? So that's the idea of big data system. They put data together, and then you can perform analysis at that point, right? Create a business application of that. Comparing between the two, data lake and data warehouse, right? Well, you can think of data warehouse like, did you learn the concept of data warehouse in database course? Yes or no? Just want to know whether you know it already or not. Whether what data warehouse is. You know what is data warehouse? What data warehouse is? No? All right. So data warehouse is a database. Yeah, just like that. Data warehouse is a database, right? A database that contain the summary of all the system together. That is data warehouse, right? So when you have data warehouse, you have the summary of all the process in the company all together at one point. So the idea is that once it is at one point, you can use the business intelligence application to tap into this and then create visualization. That is the data warehouse, okay? In terms of technical aspect, data warehouse is just another database, all right? Another database that pull the data from every point into just one database, okay? So when you compare the data warehouse with data lake or big data, there are certain aspects that each of these are good and not good. For in terms of the data itself, the data that you store in the data warehouse will have to be structured data, right? Have to be structured data, while the data that you store in the data lake can be any format, can be structured, semi-structured, it can be raw data. Simply speaking, you need to store table here. Need to be structured. You need to store table here. For data lake, you can store image, you can store video, you can store whatever file you can store in the computer. All right. And the way that you process the data for data warehouse is called schema on write. While for data lake is called schema on read. So what does that mean? How do you create a database? Can anyone explain to me? How do you create a database? Come on, you passed the database course already last semester, right? How do you create a database? Tick tock. Choose the type of database first, and next. I thought you need to open computer first. Turn on computer. Oh, I forgot. You need to plug in the computer before that, right? And turn on the computer. Log in. Right? Nah, thanks. I choose the type of database. Come on, create database name. the command. Okay. Yeah. Right. Actually, the thing that you just post here, create database with name, create table with and relation, that is the schema, because you need to think about the schema first, on which table link which, right? So that is schema on write. When you want to write the data, you need to think about the schema to store. Why for data lake, you can just put the data there first, like the CSV file, put it into big data, the Excel file, put into big data, right? Or the data in text format, whatever, you can put it into big data first. It's just like a file system that you can just put data in. Afterward, you can define how to read the data later. That's called schema on read. Once you want to read the data, you can just decide on how to read the data. Just like when you want to read CSV, you can just read the CSV and define the column type later on. So this is different between the two. Okay, and the storage design, in terms of the price, data warehouse is more expensive, and big data is lower, comparing per megabyte. Okay, per megabyte, data lake will be less expensive. In terms of configuration, data warehouse has fixed configuration when it just has one system. While data lake, you can reconfigure it into many types of systems, so it's quite configurable there. In terms of security, though, in data warehouse, because it has just one unit to do the job, the security is quite mature. For data lake, there are a lot of interaction between systems, so it's kind of maturing, means that still development. Right now, it's okay. It's already fine to a certain extent. Has been used in a lot of companies, right? The data warehousing here to make it process faster and doing things like high intensity computing tasks. People who use the data warehouse is mostly the business professional, and those who use the data lake is like data engineer, data scientist, right? In that, so this skill is quite important. How to create, how to deal with the big data system, because this is the highly sought of skill for you guys. Okay, once you gather the data, then it comes to perform data analysis to gain insight and perform business action. Right? The process is like this, right? For the data scientists, we need to get the raw data and then aggregate data, get the results and obtain the insight. Then a business professional can use the insight to make decision and then do the operation, and then you have financial impact there. Let me put it into example here. If the data scientist team and business personnel agree on creating an upsell model. Upsell model is like you want to find all the targeted marketing model. That is, suppose you have a product and then you want to sell this product, but you have a list of customers, you don't know who to contact first. You can use the previous data to rank customers so that you know which should be called first. Right? Data scientists will have a job to rank that, to create a model that rank that automatically based on maybe the chance of sales of the product. And then business personnel can use those lists to make decisions, to call, and to create the operational impact, to create the sales, and then you would have the financial outcome and the value later on. Okay, so these are the process of big data analytics. The big data analytics itself occur at this point by data scientists, but the results of the big data analytics would impact the business outcome. And that make big data become one of the popular topics that have been discussed in the past 5 years, because it allows you to improve the efficiency and productivity of the company, of the organization. It allows you to understand customer, create new revenue source, and improve the profit by sales more, by reducing the cost, right? By using system. So basically, when we talk about big data analytics, it is a principle that allow you to extract knowledge from large data set. So we will talk about how to uncover hidden pattern, find correlation, doing things like in the data model class, right? But we will do it in the big data systems, which allow you to perform computation of the data that is larger than just one computer can achieve. Right? In terms of analytics in big data, right, there are basically 3 types. Descriptive, which analyze what happened, at the moment. Predictive, which aims to analyze aim to predict the possible outcome, and prescriptive, that trying to make recommendation on the action that customers should take. So each of these would create values for the company. Okay, and because of the new way of analytics with customer data, companies around the world, including Thailand, try to create people with skill in big data and then incorporate the big data into their business. Right. So these are the aim of many companies to do this. But the company have to learn as well that it cannot just jump to the doing optimization directly. Usually there is a transition of the use of data in the company, especially the use of the big data, right? Usually they will start off with the creating ad hoc or dashboard to have the information about the moment. And then after they can incorporate prediction into the system, then they can perform something like the predictive analytics, predictive modeling, and up to the optimization to find the best solution automatically to create the AI out there. So these are the transition in the company. Back in 2014, I think, yeah, 2014, I start provide consultant to AIS. Right. So the first thing that I did in that project is to provide consultant on how to create dashboard using big data system. That's 5-6 years ago, right? And I have been closely involved with the company AIS for the past 6 years in the transition of the company from not having anything about the big data and data science to the company right now that is one of the leading company that have the big data team that can perform create a model. So what we at AIS trying to perform, I mean your seniors that work there, and I also provide consultants on the project that they should do. First is to create a dashboard, and then back then 5-6 years ago. Right now we are working on something like creating a model to find out what you like, and then trying to sell that to you guys. So yeah, that's the company task. Yeah, but they kind of trying to identify that. But this is different than you may have heard about selling the data, right? That some company kind of illegally sell the data. But right now, because we have this PDPA, which is the law that was passed, I think, at the last year, that allows data protection. And that makes these companies have to aware that they have to take care of our data, and we have the right to the data that incurred in that company, right? So yeah, the transition will start from just viewing the data into something like creating an AI, right? So it will grow into that direction in most of the company. And I see that in many companies, not just in telecom, in retail, in banking, it also goes like this as well. So if you ask me, you want to improve skill in big data analytics, in data science, I would suggest that creating a skill on each of these topics, right? If you can create a dashboard very beautifully, very effectively, that would be great. If you can create a model, that would be nice, right? You can use optimization, that would be even great, right? But you need to also understand business counterpart of this as well, because there's no such thing as having a model without business, right? Without the business solution. You need the model has to come together with how to deal with the process, how to sell the product, how to advertise. So it comes together with that. Okay, so this is the growth of big data in the company. Now let's talk about the big data, inside the big data. The concept of big data as data lake is like this, right? We usually have the data in the data source, structured data, and unstructured data. That can be the raw data, the email. If we have a stream that pull the data together at the reservoir or the lake, we call this data lake, because it's like we pull the data together here. And from this data lake, we can create the outflow, like the outflow let's say this is the result of data analytics. That is, this small stream can be used to be consumed and then used by business user to perform the task that they need. Okay, this is the concept of data lake. Now, this is the conceptual way to think about that. If we think about the system, it will be different, because the big data system or the data lake looks like this. So think about each of these blocks as a computer. You have a computer that is called name node. You have a computer that is the backup node to the name node. You have a network system that connects everything together. And then you have the data node, lots of data nodes to store data. Right? So what is big data system physically? A cluster of computers, meaning that computers connected to one another as a system, right? So in terms of physical, these are just computers that connected to one another. And then you install the OS, you install the software that allow them to connect to one another, the Hadoop software, right? And then it kind of perform the task of redistribution, the task of MapReduce, that what we'll see later on in this course that can be offered, right? So it would perform distributed processing and storage for us, right? And once we have big data, we can use this to support the data analytics, data science, to create the automated triple T that would, again, to drive the company. So you can see that there is certain dependency between them. If the company do not have a way to processing the data quickly, then it will not have the support to the data science team that want to use the data to perform analytics. If the company has the data engineering part, like the big data part, then it can create the data science team that is on top of this again. So, so you can see that these are the components that are required in order to create the data-driven culture in the organization. TDD stands for data-driven decision making. Right, this is a practice that you can that based on the decision, right? That decision should based on data, and data science is the way that you extract information or insight from the data. And that can be done automatically by creating the system like this one. This can be something like a churn prediction system. It can be upsell prediction system. It can be something like the recommendation ranking, like you find in YouTube, you find Netflix, like that. And why the big data is the support, allowing you to process the data in massive scale. Okay. Right, let's take a look at examples of use case in big data. Okay, I have a number of use cases and then we are done for today. Okay, let's take a look at the use case. This is the use case that often find in the company that the company, so the one that I put the red box here is usually this is the big data Hadoop system. Right? It taking care of the storage of data. Then you can put the data in by you doing it in batch. Batch means putting data into large file, send it, right? Micro batch means you have like a smaller one and then send it more often. Real-time ingestion means once the data occur, it transfer from source to the system directly, right? So that's the ingestion. Ingestion means putting the data into the system. I think about it that way, right? I'm not referring to the exact definition, but that's the way to think about it. Ingestion is about ingest, eat, right? It's about putting the data into the system. Why once you put the data into the system, you can perform analysis. And then you can create insight, and that insight can be a batch insight. It means that you can create a report every month, and that's batch insight. Getting batch ingest, you get batch insights. Or you can have an interactive insight. That is when people want to know about things, they're just coming in and then interact with the data, like what we will learn in the Tableau. You can have the real-time insight that the dashboard itself that you use for monitoring update all the time, just like what you see in the dashboard of the car. And that allows you to understand the moment and make decisions on that, right? So this is the data lake architecture that often occur in the company. What can be used about that, right? You can use big data to, for example, in telecom, you can use it to predict who will change, who will terminate the contract, who will churn, right? By using the usage data, using the data from customer care, the data from the customer itself, and then and the database in the company to create a machine learning model and make prediction on the churn score. And then the retention people can use this score to call customer to offer the thing so that they would not go. This is not limited to just telecommunication, right? Because right now, if you look around, you see that businesses have changed. Right? It changed into the way that is different from the past. Like if you think about the past, when we see business, we often see something like you buy something, right? You buy and you own that, right? But if you think about software or games right now, it's more like renting, right? It is subscription basis. That make the product cheaper, but at the same time it also create a problem of churn. That is when you use product of one company, you play games on one side, you often use the time to play a game or use that product or resource to do that rather than use the competitors, right? So the company want to know who will change the side, who will change to use the product from their competitor, and that is come with. And that makes the churn prediction quite important. Using big data, you can store the customer data and the authors to the big data system and perform analysis and then get the result out. Right. Next is the big data in digital marketing. Okay. The big data can be used to target specific customer to view it by gathering the data from the channels like website or mobile or the authors and put the data into the data source, ingest the data into the big data system and write a model based on based on machine learning or based on what the concept that you have, the algorithm that you have. And you may have a list of the ad that should be targeted. Then you can use that list to drive the website to show that to the customer. So this will create a loop that performs digital marketing automatically, okay, by using big data as the necessary component to perform computation. Well, you can think about, well, we can actually replace this big data with some types of processing server. But if you want the response time to be fast, then, well, you need to use a high performance system. Big data is one of that. You can use big data in detecting fraud. This is the fraud that occur in Europe, in US. In North America, this type of fraud costs like billions, and that occur. That occur globally. In North America, it's about like 500 million that occur. That have happened in the last year, in 2013. So what this is called Wangiri attack. That means this person miscall, right? Kind of miscall those that are around him, around this node, and some of the victim call back, and those that call back will be incurred in terms of the charge, because well, in Europe, in US, there will be a special premium number that people who receive the call receive the money, right? And that's premium number. So they're trying to do this to well, create a fraudulent transaction to earn money, right? So by looking the graph as a pattern, we can see the pattern that the fraud will occur like this. And in terms of time, we can see that it occurs at specific time. So these are the insights that we can get from the data. But without pulling everything together, it will be hard to find this type of patterns. So in fraud detection, things have changed, changing from storing data in a number of databases, and it create a type of ETL to do the batch processing, copying the data to one database, right? That's the traditional approach, and create a rule to do that. This is the traditional way that have been used even now in many companies. But rather than doing this, we have a way to do it in a big data way by changing from batch to the real-time ETL. That is, you can copy the data from the source to the system in real time, and using something like anomaly detection algorithm, which is a type of statistical process of machine learning that allow you to learn the normal pattern and then detect the anomaly to do the job. Then it changed from rule-based to machine learning, and you can even use the graph analysis in this. You cannot do that in the traditional database. What is graph analysis? Think about discrete math, right? In discrete math, actually in my class, like last semester, you learn about the iGraph, right? To do the graph analysis with iGraph. With the big data, you can perform graph analysis. There is even a package called GraphX, allow you to perform graph analysis on the big data system, creating graph model, analyzing the cluster of the graph, identifying the measurements in the graph. And instead of silo data, I mean that you store the data separately, you can have the data that combined it into one, like data lake. And then again, the price, right? Because instead of having scale up hardware means that if you want to have a better performance in the traditional system, you need to pay more, right? Pay more in scaling up the hardware. Instead of doing that in the big data system, you can just add node, add more computer to the system. And that is actually more economics, a lot cheaper to do the job. Okay, so that's the big data in fraud detection. Big data in banking can come in many ways, because in banking, there are a number of data available, like you have spending pattern of customer, you have income of customer, data from saving account, data from credit card, data from loan, data from the credit scoring in the loan, data from social media, right? To store everything together, to perform analysis of customer, you need a system to do that. So that's why big data is necessary there. This is another example of the financial application, but not in terms of banking. Like this is the big data in the financial compliance. If regulators like Bank of Thailand want to know whether there are any transactions that violate the policy or not, they can store the data together, the data about the chat, the communication of the company, and the data about the trading together, and then ingest the data into the system clean and create a model to rank which message that is sent that might be fraud, right? That might be a problem. To do that, the model itself needs to classify the message. Well, the message is text, so it needs to classify text data, right? You need to have an ability to do the graph analysis to identify the which involved with which, right? Which people involved with which people. For example, if this email sent out, who received them and do they forward that further, and does the action of those individuals have anything to hint that the fraud occurred, right? So the graph analysis would allow you to identify that. Well, and then the text analytics, which the regulator might want to understand what is behind those texts, what are the maybe sentiment, or sentiment mean whether they are like complaint or whether the fraud occurred by looking at the text content. Right, I already showed you this. Big data can occur in retails too. So from that, I asked you what do you think about what happened there and how big data played a role there. You can see that there are a lot of ways to gather the data, but there must be a point that these data are gathered at one place, and that the big data repository here on the cloud, big data on the cloud, and it allowed us to do the fast processing and allow the maybe the monitoring team to do the action. Okay, so in the online or the offline retail store, big data can be a complement to, it can be the foundation of the infrastructure that allow the company to perform analytics of data in almost real time, right? Big data in marketing, right? In the actual television marketing, you can use big data to accumulate the log and then analyze what happened when the advertisement go up, whether the user come to buy a product or visit the website, and then you can view the difference between when the advertisement is on and when it's not. Okay, whether that increase the productivity or not. Right, for insurance, so the new type of insurance might rely on the use of the device to do something like Internet of Things, and this Internet of Things would kind of provide sensor to the data storage. Not sure if you see this. Okay, let me put it here. All right, so it report the state to the data store. You can use big data to store here and perform the analytic as well to get a feedback to car and to home, like that. So in the motor insurance in the future, big data will be a critical part in data gathering and in creating an AI or creating an agent to respond back to the customers. In terms of the company itself, big data can be used here as the way that allow you to store data and pull the data from different sources together and make use of that to do something like performing claim management or detecting fraud, right? Do these different tasks in terms of the modeling. This is an example of big data in credit card. Back in 2000, I think that's 2015, right? I, together with another Ajahn from People, we provide consultant to one of the biggest bank in Thailand to make credit card recommendation like this one. So what we did back then is to use the merchant data and the purchase history to create a recommendation system. This recommendation system will recommend product to each customer or each bank customer, and then application can then draw on this list to make use of that recommendation. Okay, think about this as just like the engine underlying Lazada and Shopee. When you visit Lazada and Shopee and then browse the web, you see that the list in the product change according to your behavior, and that because it contains this type of systems. Okay, and you can see that there are trends that technology will play a part in public transportation, like in peer-to-peer. Well, some of that occur in Thailand, some may not, like in real-time management of traffic, which not happen in Thailand right now. Hopefully in the future, it may happen. right? And many other things. These would generate different types of data like video data, data from a sensor, the data from tap in, tap out. These data contains different format. And if you want to analyze them together, you need to have a system that pull the data all together here. Right? That's why big data is important there. Big data and AI and machine learning can be used in other fields like health, because data in the data in health contain data that are unstructured, like the sensor data, record data, and the genetic data. So these different types of data can be combined and analyzed to do something like this, to highlight what threat that the patient need to be concerned with, or you can have something like predictive model to predict whether whether the patient would have certain disease or not, or what type of prognosis, what type of treatment that they should take. In Thailand, agriculture is the main, we are agricultural industrial country, right? So to increase productivity in agriculture using big data and allow us to do something like optimization on farming decision, or you can make, when you store data, you can detect the pattern and then possibly make proactive decision, something like what to plant, or you doing the real-time monitoring of the things that are related to farming, like the wind and the temperature and humidity and the others. Okay. And the latest trend is to use big data in HR, right? To perform data acquisition and retention on the workplace, right? Many of the companies I work with, they have this problem about the talent that often go, and also the usage of the welfare. So if some of them have initiative to do the big data, collect the data from of these employees that they work on different things, like in the project, they may have the data on working in the projects, they may have the data in the learning, and they may also have the data about the welfare, which are on the different systems. Pulling everything together will allow them to do something like analyzing the skill and the performance, and then by combining with outside data like social media, the HR can further identify people in the company, and then maybe identify who create the best impact in the company, and they can hire the people who will be in that way. Right? So this is also another trend of the big data in the human resource. And lastly, the big data can be applied to learning as well, right? How to do that? If you have a system, if you participate in something like online learning, you will know that when you leave the course undo, then there will be some type of tracking system that will contact you, so that you have to come back and then complete the course, right? So it allows you to have a better service, a different type of service, by incorporating the data analytics into the learning system. And in order to collect all of the data, including the attention, including the quiz and the others all together, you need to have like one storage of data. And then it can be used to answer this question, like when you are ready to move on, or whether what grade would you need to receive, what grade is that you're likely to receive without intervention. It mean that if there's no help, what would you receive? You can use that to predict and maybe create a mechanism to help you, right, to do better. Actually, I have idea like this right now to do that for the department, that if I gather the data, your data and your maybe previous students' data, and they analyze the data to identify the patterns of learning in each class, in each course, there might be a way to identify students that may have problems in different courses in the future. And we may use that to create maybe activities for those students to prepare themselves before going to those courses. And that will help you guys in the long run, I think. So yeah, that's the big data in learning. If you collect the data from every step of learning, then you can use them, make use of them to help provide better service in terms of learning. Right, so that's all for for today. These are the introduction to the big data in different fields and the big data itself. I think this will be the only course that focus on the high level, right? The high level of big data. Afterward, we'll dive deep into the topics in big data, different topics in big data that I have already outlined at the beginning of this lecture. All right. Do you have any questions about today, about introduction? You can ask me anything about the company. If I can answer, I will answer that. You can ask me about the big data if you have questions, or maybe the future of the field, whatever. Right? Any question would be welcome. Okay, I suppose by now you should know why you need to learn big data. That is important, okay? I believe that if you know why, right, you have your own dream, right, on being computer engineering in the future. You have your own dream to do well to be expert in the field. Big data is a very powerful tool that will allow you to do a lot of things like that. So I hope that you enjoy this class and the lab and everything that we have prepared here. All right. So that's one question. How does data source communicate with Hadoop framework? How does it communicate with Hadoop framework? That you will learn that in this lecture week 9. Right, on data integration. You will learn how to ingest the data into the system, and also in week 5, right? So yeah, you will learn on that. So it's about copying the file, or you have to use the tool to do the job. From another question comes in, what the term project looks like. Do I have the example here? Let me take a look. Let me take a look at the last year term project. Wait a moment. I think I need to go into LEB too. Term project. Not here. How come? Oh, this is one. Because I teach a lot last semester. Now let me find. Oh, I see. I have used this in the first 2019. 3 to 5 assessment term project. Not here. Probably because I have like online presentation, so I don't have in the submission in the system. All right, to answer you quickly there. So what term project would look like? I would put it simple like this one. The term project should contain element that is taught in this course. Right? So you can create a machine learning on the big data using Spark operation. And then you can incorporate the workflow management to manage the machine learning so that it can take the data in, prepare data, and then do the job, right? Or if you want to do it more, you can also ingest the data from the outside of the system to do the task. Okay. Is it individual? No, just like I cannot do the individual here. So no, it is not individual. The term project is, let me put the project description that I used last semester up. Project description. So in the project, you need to, it is a group of 5 people, right? And the criteria is very like the last course that we have, but instead of focusing on just visualization and model, for this one, you need to do the project that are related to big data analytics, but whatever, you can come up with the design by yourself. Right, so for example, your project may not have, you don't really have to perform something like machine learning, but you can create a workflow that gather data online, for example, cloud the data online and then just display it. That's fine, right? So that is if the project use big data, and then you can declare on how you use them, on which part of you use them, that is already defined. So it's quite flexible there. And group of 5, right? That's like last year. Okay, any more questions? Well, feel free to post the question to the group. Okay, I will respond to the question as soon as I can. And if nothing else, let's call it a day for today. And we'll meet next time. Please install Python next time. I will teach the basic Python processing, the review of Python, how to use Python, right? And then we'll take a look at pandas, and then you have first lab there, all right? For Python, I would why did you recommend Anaconda to the student?
Yes.
All right. Next time we'll use Anaconda, particularly the Jupyter, to do the lab and to learn about these things, so that we can proceed very fast. Otherwise, it will be slow. All right. So that's it. All right. So let's call it a day. Have a good day, everyone. And if you have any comments, or if you have anything like you want to learn about this thing, or maybe I'm too fast, or the authors, or I'm too slow, please comment. So let's say, if you do not speak, I wouldn't know, right? So speak up, right? If you want me to slow down, tell me to slow down, right? If you want me to move on faster, please tell me move on faster, but I don't know if I can do that, because I think I'm really fast right now. And yeah, and if you want more materials, right? Or if you find the materials online that are interesting, share it with your friends, okay? I encourage everyone to learn topics outside the things here, outside the things I post here, and then share it with your friends. Are there any recommended book for big data? For big data, right? When I learn big data, I do not have book as well, because the technology is so fast that if you wait to read the book, I think there's a book in Thai right now, but well, mostly they will be outdated. My recommendation is to follow the online discussion, follow the tutorials, for the big data, right? Because in terms of the reference, I would suggest that the reference you should take a look at would be for example, if you want to take a look at the concept of Hadoop MapReduce, I would suggest the Hadoop website. Right? It contains better detail, right, than any author's textbook. Up to now, I still did not see good textbook in the big data, partly because it is outdated so fast, right? Suppose that I write a book on the Hadoop and Spark 2 years ago. That book is already outdated because right now both Python and Hadoop has changed its version, and the mechanism inside also changed. So it's quite hard to find a book. So my suggestion is that my part here, you can take a look at the book called Python Data Analysis. Yeah, I've sent it to the group. This free book, Python for Data Analysis. Where is it? For the Python part, take a look at this book. Right, this is for the Python part.
I think you have to reshare the screen because we see only the schedule now.
Oh, thank you. Yeah, this one. I already sent the link to the chat. You can download it. Just for the Python part. For the big data. For the big data, I will share the resource on to the website. And I think that might be better. I will share the link, the documentation that and the tutorial, official tutorial that are provided from the website to the group. I think that's a better way to learn right now for the big data itself. But I think there are books in Thai about the big data. Although I have taken a look at that, it's not so good in terms of the textbook, because in terms of the detail, it's not that detailed, and that some of them are quite wrong right now because of the updated in the architecture. So the field is changing quite fast, right? Both in terms of the platform itself and the way that you interface with that. For example, if you write a code in Python 3.6 right now, Python 3.9, you find that a lot of things have changed. Some of that I did not like actually, but well, things change fast in this area. Okay, so for my part, at the beginning of the terms, take a look at this book. For the big data systems, I will post the online book later on if I find anything that should be used. All right. So you can think of the lectures that we have right now as something like, well, you can even form a book from the lecture here and then create something like a big data analytics. Still don't have time to do that. That's the plan for like 3 years ago. I haven't had time to combine everything to write a book about this. Any more questions? No? Okay, so see you next time. Next time we'll start on Python programming. So take a look at the book that I sent you. Why? Please post this link to the group later on. Okay?
Yes.
And yeah, and I hope you guys have a good weekend. Right? Next time, so I probably will have the better camera because I use the webcam, not as good as the last time. Right? Bye bye.
ขอบคุณครับ
ครับ